called deep cycling, and most automotive batteries are not made for that kind of abuse. So I just disconnected the battery, went on my merry way, because I was told yesterday, isn't it supposed to rain like hell for the next 3 days?
Yeah.
You're supposed to be like thunder tomorrow.
Today's like a 90-some% chance. Tomorrow's 100 and Friday's 67.
Nice.
Yeah, it's supposed to be thunder tomorrow.
No, I'm trying to go home.
At Birdie High.
It's supposed to say that the area will get it, not 100% chance. I'm saying that the area will get it. Just depends on when the rain comes.
Yep. So, the thing about that is, if you're going to be working on cars outside, better get it done now before it starts raining. Yeah, working in the rain is very bad. It's like working in the dark. You don't want to do it unless you have to. It's always bad. So, this is the new setup where BCM controls everything. You know, BCM is also controlling all the rest of the lights. That's why, like on modern cars, if you shut the door, if you get out of the car and shut the door, it takes like 15 seconds for all the lights to go out. That's because it's all BCM controlled. Alright, so let's go back to this little rascal here. We're testing the switch. We're going to use an ohm meter. I guess we could use a continuity checker. That way it would like give us some sound. Same thing. It's a ohms test. Alright, so we're going to leave this. Wait, is this switch normally open or normally closed?
Normally
Open.
It's normally open because when you have something drawn, it's always drawn in its de-energized state, which is to say its natural state. So this thing right now is open, which means it has infinite resistance, which means if you put the two leads of your ohm meter to it, it's still going to say OL, because it's just like having your two leads like this. The resistance is so high it can't even measure it. Alright. Again, do yourself a favor before you use any ohm meter test. Hit the two leads together and make sure that your leads are in good shape. Otherwise, that could be causing a big problem that you think is a problem, but it isn't really a problem with this, it's a problem with that. Alright, so now I close the switch, and what happens to my resistance? Yeah, it goes low. Should be real close to zero. Probably won't be zero, but should be very close. Okay, so that's the bench test. That's the bench test, which means I'm not flowing current through it. How could I do an active test? Well, let's go like this. I'm going to have this, 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 this. 9 volts. Ah, it's 12 volts. Fine. That's 12 volts. There's B plus. Okay, so I'm going to come over here like this, and I'm going to connect to my switch.
What?
Yeah. All right. Now I'm going to leave the meter on ohms.
No.
No. Because now you're dealing with power, right? I'm not going to leave the meter on ohms. What's it going to be on?
Volts.
DC.
Volts DC is correct. Thank you. And I'm going to come over here like this, and I'm going to put one lead right there. Negative side of the battery. And I'm going to take my other lead. Put it on the other side of the switch. Caleb, what should that read?
What should that read?
Yep.
On the voltmeter?
Yeah.
12 volts.
Look at the drawing.
0.
Yeah.
0.
0. Why?
Because it's not
Because
connected.
it's switch is
Good.
not in contact.
Good. Good. You don't want to stay here for. You don't want to stay in. You don't want to stay in this town forever. No, you don't. Good. Oh my God. I forgot all about that. But I remember now.
What is your shirt?
I'll show you. You'll be tripping.
Valentine's.
Even better.
You Betty?
It's brown and 3 teddy bear food for his shawty.
Andrea Villa got her job.
Oh.
How did it go?
That's right.
Now
Big
she
Mom's
has a
so
life.
pretty.
Now she has a life. Don't take crap from nobody.
I'm not gonna.
Job. You know
What job
why?
did she
Because
get?
she freaking listens. Industrial maintenance mechanic, industrial maintenance electrician.
That's right.
With a hard hat and this. Now she has a life. And even though she went to the same loser schools you went to, surrounded by the same losers you're surrounded by, 0 volts. Because it's a voltmeter, right? Okay. And when I close that switch, what's the voltmeter going to read?
12.
12. Good. Yeah. Yep. That's an active test. See, this is active means energized. That's an active test, that's a passive test. See, sometimes stuff will pass the passive test and it won't pass the active test. Because when you're actually flowing current through it, that's often a different thing. But that's how you do it. Now you can put it in the circuit and see if it works. But that's often a lot more work than you really want to do. Alright, so let's see. Go ahead and erase that right there. We're back here at the circuit. The circuit for the starting system. As you can see, it's got a bunch of parts. And we can see that if there's significant resistance in any part of this, the circuit's really not going to work that well. The high resistance is what we're really going to look for, because when things are worn out or things weren't working well, typically high resistance is going to be a factor in that. If I have high resistance in my starter motor circuit, which is to say the power side, Jordan, you tripping? Yeah, huh? Because we're supposed to be playing with bracelets instead. If I have high resistance in a motor circuit, what's my symptom going to be?
There's a gap, a hole, or something.
I have high resistance in a motor circuit. What does resistance do to the flow of current?
Slows it.
Slows it down.
It'll be harder.
Slows it down?
You get less of
It changes the speed, you get less of it. Yeah. And when you get less current and the voltage remains the same, the watts goes down, right?
Mhm.
Okay, and there's 3 ways we know work is being done: heat, light, and motion. Okay, so what are the symptoms going to be of high resistance in the motor circuit?
Less motion.
Less work is being done.
Less work is going to be done, which means what happens to the cranking speed?
Slows
It's gonna
down.
slow down.
Yeah, it's going to slow down. Now, there's a whole bunch of people that are going to say, oh, well, I must have a bad battery because my starter's cranking so slowly. Well, maybe. Caleb, what's the easy way we can tell whether the battery is low?
You can check it with the voltmeter.
You can check it with a voltmeter, sure. Now, if you have a voltmeter, you can check the battery. It should be 12.6 to 13.2 volts DC, unless it's one of those lithium iron phosphates. But it should be 12.6 to 13.2. If that's what you got, I doubt the battery is your problem. What I'm going to do myself is I'm going to turn on the headlights. Yeah, turn on the headlights. If the headlights look like their normal brightness, that's probably not the issue. Now, as far as that went, if I could get my little ohm meter, if I could get my voltmeter close enough, I could check the voltage across the starter motor, see what kind of voltage I got, because high resistance is going to cause voltage drop, which means I'm not going to get 12 volts from here to here, which, if I had 12 volts from here to here, the starter motor would crank normal speed, right?
Mm-hmm.
Okay. Well, typically when a starter motor goes bad, this part doesn't turn, but this part kind of goes click, 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 click. You're like, Easy way to do it. Pull your headlights on. Go out and check your headlights. Your headlights look dim. Well, your headlights look dim. Probably battery. Could be the connectors. But probably the battery. In which case, a jump start would be helpful and effective, right?
Yeah.
Mm-hmm.
Yeah. Okay. Yeah, this resistance thing kind of complicates the matters, but it's nothing we haven't seen before. Now you'll notice there's no fuse in this circuit.
No wonder.
Yeah, there's no fuse because the freaking current is so high. Called inrush current. Current really goes. However, there's a fuse on this side. And you can see that there's like 4 or 5 switches in series, all of which are potential sources of resistance. And the problem is with resistance in this circuit, you're not going to get enough current on that coil. And when you don't get enough current on that coil, you're not going to have enough energy to pull this switch closed. So whether it's on the control side or whether it's on the power side, resistance is going to be a problem for us. Now, I got to tell you, 80% of the vehicles that come in here are going to have dirty, corroded terminals. And those dirty, corroded terminals cause all kinds of problems. Really, one of the most significant problems this is going to cause is your alternator is going to sense that your battery is low, and since your alternator senses that your battery is low, your alternator is going to start pushing and pushing and pushing and pushing and pushing and pushing and pushing. And the problem is, for the alternator, when you work it extra hard, it dies sooner. Back in the 80s and 90s, Ford had this significant, really significant problem with the battery cables that went to the frame of the car. Always got high resistance in them. So as a result, the alternator was working all the time trying to charge up this battery. It had a bad ground. And failing, which is what chewed up the alternator. Also, since there was high resistance in the circuit, the starter motor was not getting the voltage it was supposed to get, so as a result it kicked up the amperage, which fried the starter. So basically what people do is they were replacing the whole electrical system, because they were replacing the alternator, replacing the starter, and replacing the battery. And it still wouldn't fix it because the problem was the cable. High resistance in the cables causes problems. But anyways, back to the starting system here. We talked here out the passive or bench test. And that is a de-energized circuit. That you can use an ohm meter for. Problem is, the ohm meter only passes milliamps. There's lots of stuff that'll work fine with milliamps that'll fail if you try to put any significant current through it. That right there is much more active, much more accurate test, but the problem is now you're dealing with voltage. No more ohm meters, because we never use an ohm meter on an energized circuit, right? This is called an active test. Because we're actually using real voltage and current. Which one of those is more dangerous? The active one, yeah, sure. You know, and while we're working with 12 volts, it's really not that dangerous. But, you know, if we're working with 120 volts, it has the potential to nail you. And, you know, we got modern battery operated vehicles that are running 440, 480, 700 volts. Which is why, even though I have all the tools and all the equipment, nah, I'm not doing that. I'd love to tell you what we did yesterday, but yeah, so that's an active test. You know, tell me if there's voltage in there, please.
No more.
Oh. Right. Ignition module.
Oh, the outlet?
All right, there.
One 119 volts.
119 volts.
Yeah.
Okay. That's a dangerous test.
Yeah.
Potentially, I mean, yeah. Sure.